So yes, thanks for the invitation to give a talk on modular plants technology for chemical plants, to give an update and some perspectives. Yes, I'm talking here as representative from Process Networking Group Modular Plants, and representing all the companies that you see below here that are working together on that on that topic as well. Yes, my name is Franck Stenger from Process and Evonik Operations GmbH. And in my spare time, in inverted commas, I'm head of that Process Networking Group, and that hat I'm heading on today. And I'm also heading the standardization group of the VDI 2776, also on modular plants. So what is the outline of the talk today? I will briefly give an overview of the motivation, why we are looking at modular plants, how did we proceed in the past, and what is the modular approach, and also give you some kind of insight on the status of implementation, and of course some outlook as well. Starting with the motivation, and I think we heard a lot of things this morning already that might underline the motivation that we have. So what we see there are drivers for plug and produce concepts. And why is that? Because industry and markets are continuously changing and ask for new requirements that only can be solved by new technological solutions. And this is real not just for the chemical industry, it's also for the food industry, oil and gas, and especially pharma and fine and especially chemical industry. So what they are looking for, it's kind of a reduced time to market. I mean, this is market driven, this is business driven, but there's also a need for increased flexibility. And we were talking about flexibility this morning when talking about feedstocks, when talking about raw materials, energy, and so on. So there is a need for increased flexibility in the plant, and of course, improved efficiency as well. Especially when we look at the problems we are currently tackling with the climate change. And solution that we think that can help is modularization on one hand and standardization on the other hand, and that could pave the way to kind of a new plant technology, a modular plant technology that use different process units in a flexible way that connects the units via standardized interfaces. So really the idea is to make modularization as the breakthrough in designing future production plants that needs to be applicable not only to new and greenfield plants, but also to optimize existing brownfield plants. And when we look in the past, that journey on modularization and standardization started already 10 years ago with a kind of a conference in Germany, Tutzing Symposium, which was called the 50% idea, mainly based on the idea to reduce implementation development times for new processes by 50%. And based on that idea, there was the first big project. It was a European-funded project, the F3 factory. F3 stands for fast, flexible, and future. And maybe many of you have been part of that project. So there were a lot of companies involved, showing that it's possible to modularize process industry from a chemical point of view across a broad chemical products. So this was the start, ending 2013, and this was the point to further gain knowledge, to share experience, and to further work on the concepts developed already in the F3 factory. This was when the Process Networking Group Modular Plants was founded, and the first white paper was sent out, which is available on the web page on that as well. It was clear from the beginning that this is not only driven by the owner operators, that there needs to be kind of an alignment with other associations within Germany. So we formed the round table on modular production together with the suppliers, automation suppliers of Namur, the electronic industry, and also the possible module suppliers. So all the association joined in a so-called round table on that topic. And first outcome were joint dissemination activities on the Hanover Fair and Aachener Fair on that topic as well since 2017 ongoing. And we also started standardization work on these topics first starting with national standards under these two numbers. And finally, there was kind of the Tutzing Symposium, so a follow-up of that symposium 10 years ago, with the title 100% Digital. And in that symposium, modularization plays a central role as well. And finally, yes, we started on working on internationalization of that topic already with IEC and ISO standards about to follow. So when we talk about such a plant, a modular plant, so bring all your units in a flexible way, this is clear that this is a disruptive change in plant technology, and it needs not only one discipline, it needs the effort of different disciplines: automation, process technology, and plant design. So we need the input of all the players that you see around here: automation, controller, sensors, module plant manufacturers, plant owners, and of course universities as well. So all these disciplines are now working together in a big round table. And if you look at all the companies that are already involved, you see there's quite a broad interest in bringing that know-how and that technology further into market. Owner operators, Merck, Evonik, BASF, and so on, in the chemical industry, as well as the key players in automation technology like Siemens, ABB, but also DCS systems, Honeywell, Emerson, Yokogawa, and so on. They all joined in order to bring that technology further. So how did we start actually? We started with doing some standardization work, and we divided a modular plant approach into four different layers. So on top you have the modular plant, and that modular plant consists out of different modules. We call these modules process equipment assembly. In order not to have different definitions, it's a process equipment assembly that fulfills a certain process functionality. For instance, feed, dosing, reaction, separation, and so on and so forth. Inside these process equipment assemblies, we have some subunits that we call functional equipment assemblies, so-called FEAs, that you can exchange in order to adapt the applicable range of these peers in the production and process environment. And of course, these FEAs consist out of components, machineries, pipings, fittings, and so on and so forth. So these four layers form the basis of modular process technology, and this is written down in that standardization work that you can follow up under these numbers. And of course, there's automation technology on the different levels as well. And central is that all these pairs have their own intelligence, they have their own module automation control PLC system, and they are intelligent on their own. With having these layers, it was possible really to set up kind of a new modular plant engineering approach that starts outside the process. It starts with modular engineering and in designing standardized process modules, fulfilling a certain functionality, bringing along their own intelligence, so their own control and automation system. And out of these modules that are provided from the market in the end, you start your modular plant and decide about the functionalities they need, then they look up, okay, what modules are available on the market that fulfill my requirements. They pick these modules ideally from the module designer, and they configure their modular plant design in a new way, composing the process out of these existing modules. They put them together across standardized interfaces, especially really speeds up the whole time that you need to implement that. And finally, you bring them together in a productive environment, and you orchestrate these different modules across a simplified orchestration layer that is capable of really doing rearrangement in a very flexible and easy way as well. As I pointed out, that interface, that data interface in between the modules, that is key and that is crucial for being successful in that manner, in order to exchange certain modules and bring other modules in an easy way. And for that manner, the colleagues from the automation interface, they developed this module type package, a so-called standardized non-proprietary interface describing all the functionalities that a module, that a process equipment assembly is capable of. It brings across all the HMI that is necessary. It brings across functionalities for process control, alarm management, safety and security, and also maintenance and diagnostics, and can be easily adapted no matter what supplier is providing the module. So this is really key to have that. Maybe better to understand, you could compare this MTP module type package with in analogy to a printer driver that you have installed and that you easily plug into your PC system, and that is capable of transferring your data to the printer and assure that the outcome is what you expect. Similar is the MTP. That is kind of a device description that enables a process control layer to implement the function and services that different modules provide via the MTP. So maybe this illustrates how crucial that is to have that and to implement that. So what about the status? As I said, we have two national standardization guidelines that try to describe what I've outlined just a few slides before. So this is the VDI 2776 and the VDI 2658, describing the automation interface, and this is describing the mechanical aspects of the modular system. And you see some papers are already available in white print, so this means they are public. They are available in German and in English as well, and they are now going to international standardization, the IEC and ISO system as well. And having these standards now in place, now they allow for first commercial products and implementation as well. So now we have this kind of standardized interface, making it possible to easily connect and reconnect modules to a DCS or orchestration system. So, and of course, we started with a lot of implementations in the lab and in the pilot plants, where a lot of flexibility is needed. And this gives you an insight into an example from Evonik. So this is how we set up now our labs. So we set them up in modules. So we have the control boxes in each module available, and these are connected to the orchestration layer here, and we can easily exchange these modules in between. So it's really like plug and produce, and it's an easy rearrangement, and it brings benefit to the whole lab and to the efficiency of doing our R&D work and development work. But this is
Martin, I think we have a technical problem, maybe.
I confirm we have a problem.
I think Franck is muted.
To the HMI. Recently published, you may have read that. Also, Lanxess started serial production of modular X biomer plants. So this is the inside look inside of such a plant. It's kind of a small scale plant for the leather industry. A process that they have developed and that they are now further bringing to the market together with Hüni. And there are a lot more of these examples already existing. So this shows it's not just working in the lab environment; it's also working in production.
Franck, we have got a problem. We don't see your screen.
Okay. Yeah, I see. I have the problem as well. Can you hear me?
We hear you.
Yes, I'm sorry. Maybe I can.
Oh. We can't hear you anymore.
Is it now better?
Yes, now we can hear you again, but we cannot see your screen.
Yeah, I start again. Sorry. Is it now working again?
Yes, that's okay.
Yes.
You see the screen again? Sorry.
Yeah. Maybe you can repeat your previous slides.
So did you see that slide already? Hello?
Yes, we do.
The previous slide, please.
This one?
Yeah.
So this was the last slide. Okay. Sorry for that. So this was the example of implementing the modular system to the lab environment, bringing these benefits, yes, to the lab and development. But this also works for going into large scale plant when implementing package units into existing plants that are already operating in a monolithic architecture. And we have shown this last year at the Singapore side of Evonik, implementing a package unit, a chiller unit from NG that has an automation system of Siemens via that already mentioned standardized MTP interface into a Yokogawa system. And it turned out that this could be real. So further package units of Evonik we will implement in that new way of doing modular data implementation into existing HMI systems. And that brings me to the last example, recently published from Lanxess on starting a production series of modular X biomer plants in that manner, in order to have it flexible and in order to bring them to different leather plants. They started a cooperation together with Hüni, bringing really that technology now into production and into the market as well. So this shows that system not only works now for the R&D and pilot plant environment. It starts going into the market, into small scale production already. Yes, this gives you an insight of the work that we are doing. So Industry 4.0, the age of modular production. There are a lot of joint activities now together, as I mentioned, with the different groups, showing more and more demonstrators, hardware as well as software, and showing you how it's possible to connect these different process units in a. Of course, that's a remaining challenge. Nevertheless, it already starts, and we try to align on that topic already. If you look into the US, there's, for instance, the rapid is how they interpret process technology in the future, and this brings along, yes, these different peers as well. So it starts in the US as well. And ExxonMobil Open Process Automation, it's a forum about how to standardize these data interfaces, as I've introduced to you a few slides before. So there's ongoing alignment and validation of that topic as well. Nevertheless, there are remaining challenges. Although it's promising and we have the first implementations in place, it's a disruptive technology, and it's a technology change that really requires a mind change of the whole community. And this includes management inside the companies as well as staff personnel, really in the daily life. Yeah. And this takes time, and therefore you need good arguments, you need good dissemination activities, you need good examples that show that this really brings a benefit. So of course we will not rapidly change from monolithic or conventional plants to modular, so we need kind of a transition phase. This is still of a challenge, really, to bring in these new systems into existing plants. It's possible, but it needs some adaptations for the next time. And of course, there are still open development tasks in the field of automation, how to really realize the orchestration of all the different modules. Authority engineering. We talked about regulation this morning as well. To do that really in a flexible way, and to do that really in a fast manner. Makes no sense to be ready with your process technology and it takes years for getting the authority approval. Then this will pay off. Okay. Standardization, harmonization remains challenging. So this is why I'm happy to talk to you and bring that topic into that community and really start an exchange and work together on these concepts. And of course, yeah, new business models are possible and thinkable. So why really investing in such modules when it could be possible to rent them from the market just for the time needed and then give it back to the market? So really sharing process technology instead of bringing capex into the market. So these are just ideas that the community has and that the community is working on that could pave the way to the future plants. With that, I would like to thank you for your attention, and I'm open to questions. And sorry again for having the trouble with the slides in between.